Today, we take another look at our formal proofs, specifically two-column proofs, and we'll be looking at these using triangles with all of the rules that we've just talked about in our previous lessons. So we have a few new rules that we need to look at that we'll see popping up in proofs, not only for congruent triangle proofs, but also when we look at similar triangles and quadrilaterals in our future units. So our first property is the reflexive property. Now, this can be used especially when we have diagrams where we have a shared side or we have an overlap between our two figures. And this just basically says that if we have something, we have a side that's in both of our triangles, well, if it's the same side, then it must be a kind of corresponding, a congruent piece. So the biggest thing to remember on this one is going to be, this is always going to be our shared side, or sometimes it'll be an angle. And again, we'll see this in one of our examples, at least a couple of our examples today. Okay, next is the transitive property. Now, we don't use this too often with triangle proofs, but we may very well see this, especially in similar triangles next unit or with quadrilateral proofs that we may check out. And you've looked at this in algebra already. Transitive property is like if A equals B and B equals C, then A equals C. We're kind of transversing the expression. Again, holdover from algebra might not show up too much with congruent triangle proofs, but it might still pop up. Okay, next is corresponding parts are congruent. And depending on what resource you look at, so if we look at any extra help videos or other resources, you might see this abbreviated as CPCTC, which basically means corresponding parts of congruent triangles are congruent. So for example, if we have the triangle ABC is congruent to triangle XYZ, well then we can pick out these corresponding parts. So for example, our AB and our XY segments, well, because they're corresponding pieces of the triangle, and we are already told that those triangles are congruent, then we know the segments have to be congruent. And so again, we'll see this in a couple examples today. And then our substitution property, which we already used when we looked at proofs last time, which is really just if you want to simplify or rewrite, or maybe you're substituting a measure into a different expression. Anytime you're rewriting your statement, don't forget that's your substitution. So that would be a good note. This is going to be our rewrite step. Anytime we're cleaning something up in an expression, we can use this as well. Don't forget too, we'll have other properties that we'll see popping up as we look at our diagrams or in the given information as they're describing what's happening in that picture. And so our first is we'll probably see midpoint happening. And don't forget your midpoint, it's usually if we've got a segment and they're saying, hey, segment, or excuse me, point M is the midpoint of segment AB. And don't forget, midpoint is our point exactly in the middle. And if we know we have a midpoint, that means our two parts of that segment have to be congruent. We could also have the expression angle bisector or even bisector of a segment. We could also see perpendicular bisector. And that kind of goes hand in hand with our midpoint. Okay, so let's actually write that out. Because a bisector actually does the same kind of thing as a midpoint does. A bisector is going to be right in the middle. It's going to perfectly divide an object in half. Now, most often when we're describing bisector, we're using it as an angle bisector. So if we take an angle and we cut it perfectly in half, so a lot of times we'll say, hey, this ray bisects the angle. Well, then all that means is we're taking that angle and we're cutting it perfectly in half. So we might have, say, measure of 20 degrees and 20 degrees. Again, just like midpoint, divides the object perfectly in half, and each half is equal to the other. We've also talked about perpendicular. And so don't forget, when two lines or two segments are perpendicular, what kind of angle do they always form? Well, they're always going to form 90-degree angles. So perpendicular lines always make 90-degree angles. And knowing that that's 90 degrees may let us prove additional information. Also, one of the biggies, vertical angles. So again, anytime you see kind of this X part of your diagram. So again, we might make this into, or we might see this when we're looking at triangles. And our vertical angles, again, they are straight across from each other. So don't forget, I like to actually call this almost a bow tie diagram, because when I draw in those vertical lines or those vertical angles and I mark those as congruent, notice it looks kind of like the knot in the middle of a bow tie. So always keep an eye out for that, but be careful. Sometimes you may have this kind of diagram set up and we don't actually want to use vertical angles. So be very careful, and you'll see me looking at this as we're working through our practice proofs. Don't mark information down until you use it or until it shows up in the proof. So even though you may want to say, oh, I see vertical angle, so I'm going to mark them down, hold off for a second, because it may just be that you don't happen to need vertical angles in the diagram, even though technically that is a true statement. So let's go ahead and look at some practice proofs. So we're going to see 4 proofs today. 2 proofs are just going to be straight out, let's prove that the triangles are congruent. And then 2 of our proofs are going to practice that corresponding parts are congruent piece, where we'll have to go one step past proving our triangles congruent. So let's check out the first of our proofs. Alrighty, so in example 1, let me move this up a little bit. So example 1, we are given 2 sets of information, so 2 pairs of sides that are congruent. We do have one of these bow tie looking diagrams, so I may need to use vertical angles in this problem. I may not. We'll see what happens. And we are trying to prove that our triangle ABE is congruent to triangle CBD. So our first thing is, with any proof, again, first step should always be, let's list out the givens that they stated in the problem. So first given that we have is that segment AB is congruent to segment CB. So that was given information. We know it's true because they told us that in the problem. So let's go ahead and mark it on the diagram. Now, as you're working through these problems, absolutely, you always want to write out the diagram and mark your information as you figure it out. So very important, especially with learning this online. Again, I know you do not have a touchscreen computer most likely, so copy down your diagram and write things out as we're working through. And again, don't forget, if you need to pause the video and you want to print out a copy of this organizer, you may absolutely do that. Alrighty, so that's not the only piece of given information. We also know that segment EB is congruent to segment DB. And same thing, that was given information. So I'm going to mark it on the diagram, and I want to use different number of dash marks so I know it's a different segment. So EB, I'm actually just going to use 1 on these. There we go. So we are ultimately trying to prove that our triangles are congruent. And again, when you're doing a proof, you almost can, work a little bit backwards on this. We know that the thing that we're going to prove is going to have to be the last step. And so whatever the last space is, we can go ahead and write that in. So I know triangle ABE is supposed to be proven congruent to triangle CBD. And so they're giving me some help on here. I know that those angles have to go around in that order. So I'm going to go ahead and trace those out. So triangle ABE is supposed to end up being congruent to triangle CBD. And check out your order. So as I trace through them, we're meeting in the middle, we're meeting at that B point. And so to prove that our triangles are congruent, what extra information do you think we might need to use? Well, let's see, we have 2 sides. And so thinking about the rules that we know that have 2 sides in them, we can either have SSS or we could have SAS. And so this is actually one of those scenarios where, vertical angles is going to come in very handy because, and let me go ahead and change my color on this one. Because if I am trying to work towards SAS, having my vertical angles in the middle, that would put all of our information in exactly the correct order to use that rule. So let's write that out. And again, the problem's helping us out a little bit. Okay, I can't call these just angle B. I have to be careful of my order and be very specific, but why not just use the order of the triangle names? Just instead use that for the angle of my order, or the order of my angles. So triangle angle ABE is congruent to angle CBD. And again, notice If we're looking for the angles that are in towards the B is right smack in the middle of the name, right where the vertex is always going to be. And the reason they're congruent, well, vertical angles are congruent. We could also potentially see this as definition of vertical angles because that is exactly what our definition states. Alrighty, so now we have enough information. So we can actually say, hey, my triangles are congruent now by SAS, excuse me, SAS congruence. And again, the reason I'm going ahead and mentioning this is congruence is next unit, when we do some proofs with similar triangles, we'll have some very similar names, and we want to make sure we're very specific in the work that we're writing out. Alrighty, that's our first proof done. Awesome. Let's do another. Okay, moving on to example 2. So slightly longer proof. We've got 5 steps on here. So let's go ahead and attack it. So again, we always want to start out with what information did they give us? So they gave us that segment RS is congruent to segment TS. Alrighty, that's actually already marked in the diagram for us, very helpful. So that is given information. They also told us that V is the midpoint of RT, segment RT, again, given, but we don't have anything marked on there. So that's kind of a hint saying, okay, we're given that this is a midpoint, we need to use that information to figure something out. So again, what do we know about midpoints? What do they do to a segment, or where are they on a segment? Well, they're right in the middle. So if I know that V is a midpoint to segment RT, well, it must mean then that the two parts are going to be congruent again, because that's just right from the definition of that midpoint. So that's something new we figured out. So let's go ahead and state our congruent segments. So RV is congruent to TV. And again, we just used what we knew about midpoint. And anytime that you're doing that, you can write it as definition of midpoint. Alrighty, so what else can we figure out? Again, we're going to need some extra piece of information. We only have 2 pieces of info so far, but same kind of thing as before. We have 2 sides that are congruent, 2 sides that match up between the triangles. And the only things that I know about that have at least 2 sides matched up in my rules are SSS and SAS. Okay. Technically, we could also do hypotenuse leg as one of those, because again, 2 sides, a hypotenuse and a leg, those are 2 sides in our triangle, but we need a third piece of information, which is we need to know that this is going to be a right triangle, and that information just wasn't stated on here, although we might be able to look at that if we delved a little bit deeper into what kind of triangle we have. But let's approach this, very straightforward, very head on. Let's go ahead and for the moment, ignore the HL. And let's see if we can make SSS or SAS work. And again, I'm going to kind of work ahead on this almost, because I know that the last statement of my proof always has to be the thing I'm proving. So I know I'm going to have to end up, actually, let me change my color. Because again, this is something that we're getting right from the information in the proof. So our triangle RSV is congruent to triangle TSV. I don't know why yet, but any ideas, any way we could make this fit either SSS or SAS? Well, we can actually use the new property that we talked about in the beginning. So these triangles are stuck together. They both have a common side. So if we look at that side in the middle, VS, well, that's part of both of the triangles they want us to look at, RSV, which is this one, and TSV, which is this one. And so they both go along that middle side. So if they share that side, that's when we can use that reflexive property. So we can say that segment VS is congruent to segment VS by the reflexive property. technically the reflexive property of equality. But if you don't write the whole thing out, and if you just see reflexive, anyone who's looked at a math proof will understand what you're talking about in that step. And so we now have, let's go ahead and mark that. So we have that middle side is congruent to itself, but I want to give it a new mark. And wait a second, that's 3 sides marked in each triangle. So there's my rule. So my rule is SSS congruence, or side, side, side congruence. All right, so that's a couple examples with how we can prove triangles congruent. And it's really, again, just explaining the same thought processes we've looked at over the last couple days, finding one of those rules that matches up and making sure that we have enough information congruent, enough pieces in our triangles congruent to each other. So let's see how we might take this one more step. So 2 more examples. And these are going to look at one of those new rules again. So example 3, which let me shrink this a little down because slightly longer proof that we're going to write out. So looking at our given and our prove and our diagram, wait a second, there's no mention of triangles on this. So why is this in with triangle proofs? Because what we're actually going to do on this problem is find our congruent triangles, prove those congruent, and then angles M and P, see if we can use that corresponding parts of congruent triangles are congruent. But again, let's just see where the proof takes us and start from there. So information that we're given, L is the midpoint of KN and MP. That was given information. Well, what did we do with that in our last proof? Well, if we know that we have a midpoint, then that point is going to divide that segment in half, in perfect 2 equal halves. So L is the midpoint of KN. So that means the 2 pieces have to be congruent to each other. So let's write that down. So KL, segment KL, is congruent to segment NL. Why do you think I'm naming them in that order? Yeah, in that order, that means I'm kind of moving towards the middle of the triangle. Order is absolutely important when you're looking at congruent triangles, even though we haven't figured out which names we have. But most of the time with these problems, we're going to be going in towards the center on these. So may as well go with that pattern. Okay, and actually, I want to change the color on that because that's new information that we figured out. So let me go ahead and rewrite that. So KL is congruent to NL, again, marked on the diagram. And we figured that out just using the information about midpoint. So definition of midpoint. Okay. But we said in the givens, L is the midpoint of KN and MP. So let's look at MP now. So if L is the midpoint of MP, well, it's doing the same thing with that other segment. So let's mark our pieces congruent and write it down in the proof. So segment ML is congruent to segment PL. Same reason, definition of midpoint. Okay. So if we're trying to work towards getting these triangles congruent, any ideas on what rule we might use for it? So wait a second, we're doing kind of the same thing as the others. I promise you're not always going to use the same rules over and over again. We just happen to have them in these proofs. Okay, so again, I'm going to go back to a different color. So 2 sides already means candidates are SSS and SAS. I don't have any other information about sides, but with the triangles meeting in the middle, what kind of diagram is it? It's one of these bow tie diagrams. We can use our vertical angles right at L, but again, we need to be careful of the way we name. We can't just say angle L is congruent to angle L. But now that we have some marks on our diagram, we have a little bit more information about what order we could be looking at these in. And so if I kind of trace along going past the same things, Well, on the left-hand side, I could go triangle KLM. I went along the single mark and finished up along the double. So let's do the same thing on the other triangle. So NLP. So let's use that both for our angle names for our vertical angles and our triangle names, because why not? They're going in the same order, looking at the same pieces. So we can say that angle KLM is congruent to angle NLP by vertical angles. Technically, definition of vertical angles, or all vertical angles are congruent. And we now have enough information to use SAS. So we can say triangle KLM is congruent to triangle NLP by SAS congruence. So last step on here, we know our last statement is going to have to be what we're trying to prove. So angle M is congruent to angle P, but why? So look at our names. The M and the P are in exactly the same spots in both the angle and the triangle names. And because of that, that means they are arranged in, let's see, M and P. Well, if you look at your markings, they're both at the end of that double marked segment. So I know they're in matching or corresponding places. So our rule is corresponding parts are congruent. And again, you'll notice I'm abbreviating a little bit as I write these out, which is absolutely fine. Keep in mind, when you see these proofs on practice or a lesson check or a test, everything's already going to be written out for you. You are either just trying to, pick out from a list what's correct or match up what order your steps should go in. Alrighty, one more proof. Let's check it out. So example 4. This one looks a little different because if we look at the diagram, we can actually see a few different triangles in here. And you'll see this occasionally where we'll have some overlap in our diagram. So what I always like to do in this is before I fully complete the proof, I do usually want to draw out my separate triangles. Just makes it a little easier for me to see what's going on. And I have a little bit of a hint as to what I'm going to be looking at with this, because if we look at our given, it says angle CDB is congruent to angle AEB. Well, look for 2 different triangles that those angles are in. And so what happens is we actually have one triangle on the left, one bigger triangle, and then go to a different color, and then one triangle on the right. And so what I'm going to do is actually draw out my triangles separately, and that will help me figure out, how these different pieces are related. So let's draw that out. Okay, so first triangle, and again, this doesn't have to be perfect because we're going to label everything and mark our information as we figure it out. So if drawing these out, it doesn't look perfect, please don't worry about it. We do have angle E marked in here, so I'm going to go ahead and write that in. And then we have our right-hand triangle, which again, I'm going to do in red, just so it kind of matches up. And he kind of looks like this. And again, B is at the bottom, D is on the left, C is at the right, and we had an angle mark right there. All righty. So let's attack this now that we can see our 2 separate triangles. Alrighty, so let's write down our givens. We are given that AE is congruent to CD. So those segments are congruent. That is given information. Sorry, trying to round my notes real quick to make sure I have everything written out properly. Alrighty, so is that marked on the diagram? No, not yet, so let's mark it in. So AE is congruent to CD. Alrighty, so far, wait a second, we have an angle marked and a side marked. The angle we have marked is actually the information that was given in the diagram. So again, let's write it out. So angle CDB is congruent to angle AEB. That information was given. And notice too, the middle letter kind of gives away where the angle should be centered. So we should have one angle at D and one angle at E, and that's exactly what we have in our diagrams. Alrighty, so we're actually 2 steps away from having congruent triangle. Well, 1 step away, really. So far we have a side and we have an angle. So let's think about the possible rules we could use. We could use SAS. We could use ASA. We could use AAS. See, HL we could use, but again, do we have any right triangles or any kind of inclination that that would be a thing in this proof? Yeah, not so much, so I'm not going to consider HL right now. So let's think about this. Eventually, we're going to try to prove that our triangles are congruent. So again, let's write that out, but I can't prove them yet. I need one more piece of information, so let's put that in step 4. So triangle. Actually, let's do this. So triangle CDB is going to have to be congruent to triangle AEB for this to work. We just don't know what rule yet. Anything else in common between these triangles that might help us out? Look at your names. Do you have anything in common between your names? Oh, wait a second. Both of these have a B in the name. And if we look at the original diagram, we have this B down at the bottom of our diagram. Isn't that angle B part of both triangles? And so if it's part of both triangles and it's the same exact angle, well, then I know it has to be congruent to itself. What's our rule again when things are congruent to themselves? When we have a shared side or a shared angle, we can actually use that reflexive property again. So we can say that angle B, although let's go ahead and use our 3 letters on it. So let's say angle CBD. So I'm kind of flipping around my order. I want to flip it around the same way to make sure that B is in the middle. So angle CBD is going around this way. So I need to go around the same way in the other triangle. So angle ABE. Those are congruent because they're the same angle. So that's reflexive property. So now, what rule can we use to prove these congruent? Well, with the information we have marked in the diagram, we have 2 angles and a side. The side is not in between the angles. So that means I'm going to use my angle side rule. That's why my triangles are congruent. So angle side congruence. And now we should have enough to prove that our segments are congruent. It is the last step in the proof, so we know we should be there. So AB is congruent to CB. Well, look at the names in your triangles. Are the letters in the same order? So we have AB here, and we have CB here in exactly the same order. So we can say corresponding parts. Corresponding parts are congruent. Alrighty. Again, when we're writing through proofs, you're always going to be told, how long is the proof, or you're going to be given some information of where things are filled in. So please don't worry about not knowing exactly what order you have to go in. Again, you will not need to write one of these out completely by yourself, although hopefully by showing you writing these out without those extra pieces of info helped along with the logic a little bit of how these are put together. So please do check out your practice next. Make sure that you have your proofs written down. It will help you remember and give you a good reference to look at. And let me know if you have any questions.